Question 1. An example for an oxidation reaction is, we're given four options. Oxidation is a process in which species loses electrons. Therefore, in A, B, and D, if we see, the species accepts electrons in it. Therefore, this are the reduction reaction. While the reaction in option C, if we see, that is half of H2 gives H plus electron. This species is losing an electron in this reaction. Therefore, option C is an example of oxidation reaction. Therefore, option C is a correct answer. Question 2. The conductors of four electrolytes in per ohm per centimeter are given below. Which one offers higher resistance to passage of electric current? Conductance is reciprocal of resistance, that is R equal to 1 upon C. For higher resistance, lowest conductance is required. Electrolyte with lowest conductance of 9.2 into 10 raised to minus 9 per ohm per centimeter will offer higher resistance. That is, if we see, option B, that is 9.2 into 10 raised to minus 9, is the correct answer. Question 3. Conductance of 0.1 nitric acid is 6.3 into 10 raised to minus 2 per ohm per centimeter. The molar conductance of solution is, we're giving four options. So the molar conductance, that is given as 1000. This is 1000 K upon C. Therefore, we can substitute the value. We have K as 6.3 into 10 raised to minus 2 upon C, which is given as conductance as 0.1. Therefore, we solve this, we get 630 per centimeter square mole per mole. That is, if you see, our answer matches with option C. Therefore, option C is the correct answer. Question 4. The molar conductance of NaCl, HCl and CH3CO Na at infinite dilution are 126.45, 426.16 and 91 per ohm centimeter square per mole respectively. The molar conductance of CH3COH at infinite dilution is given as, we're given four options. So we can write the molar conductance for CH3COOH equal to molar conductance of CH3COONA plus HCl minus of molar conductance of NaCl. Therefore, we substitute the value. We have 91 for molar conductance of CH3CONA, 426.60 minus 126.45. Therefore, we solve this, we get as 390.71, that is per ohm centimeter square mole per mole. That is, if you see, our answer matches with option B. Therefore, option B is the correct answer. Question 5. If the molar conductance of one benzoic acid is 128 per ohm centimeter square per mole, and if the conductance of benzoate ion and H plus ion at infinite dilution are 42 and 288.42 per ohm centimeter square per mole respectively, its degree of dissociation is given as, we given four options. So for the benzoic acid, we have molar conductance of benzoic acid, that is C6H5COOH equal to molar conductance of C6H5, that is benzoate, plus molar conductance of H plus ion. That is, we substitute this value, we get 42 plus 288.42. That is, when we solve this, we get 330.42. Therefore, degree of dissociation can be given as alpha equal to 128 upon 330.42, which is equal to 0.39. Therefore, alpha at percentage we get as 39. Therefore, our answer matches with option A. Therefore, option A is the correct answer. At 25 degrees Celsius, conductivity of normal solution of KCl is 0.002765 per ohm. The resistance of cell is 400 ohms. The cell constant is dash. We're given four options. So the cell constant can be given as B equal to K into R. Therefore, we can substitute the value, that is, for K we have 0.002765 into 400, that is our resistance, which is equal to, we solve this, we get 1.106 per mole, which is, we see our answer matches option C. Therefore, option C is the correct answer. Question 7. Electrochemical equivalent of a substance is the quantity liberated on the passing electricity equal to, we are given four options. We have W is equal to Z into I into T, where we take Z into Q. When Q is equal to 1, that is 1 coulomb, and that is where I equal to 1 ampere, and W is equal to Z. Therefore, that is the amount of substance liberated is equal to the electrochemical equivalent. Therefore, we see condition satisfies at 1 coulomb. Therefore, we see our option B, that is at 1 coulomb, as a correct answer. An electric current of I ampere was passed through a solution of an electrolyte for T seconds, depositing W grams of the metal M on the cathode. The equivalent mass E of the metal will be, I give four options over here. So we have Z equal to E upon 96500. That is, we get E equal to Z into 96,500. That is, we also have Z is equal to W upon I into T. As we substitute, that is, we get E equal to W into 96,500 upon I into T. So therefore, we see our answer matches with option C. Therefore, option C is the correct answer. Question 9. On passing electric current into a solution of a salt of a metal M, the reaction taking place at the cathode is M2 plus 2E, which gives us M. The atomic mass of M is 65. The equivalent mass of metal is given as, we are given four options. So the equivalent mass can be given as atomic mass upon valency. So if we see the reaction, that is M2 plus of 2E gives us M. If we see our valency is 2 over here, so that is atomic mass is given as 65 upon valency, that is 2, which we get as 32.5. With this, we see our answer matches with option D. Therefore, option D is the correct answer. Question 10. The time required to pass 36,000 coulomb through an electroplating bath using a current of 10 ampere is, we are given four options. We have Q given as 36,000 coulomb and I equal to 10 ampere. Therefore, we have Q is equal to I into T, where we can find T, which is equal to Q upon I. So therefore, that is 36,000 upon 10, which is equal to 36. That is 3,600 hours. that is nothing but 1 hour, which is, we see our answer matches with option B. Therefore, option B is the correct answer. Question 11. The quantity of electricity needed to liberate 0.5 grams equivalent of an element is, we are given 4 options. Electricity required is equal to number of grams equivalent into 96,500 coulombs. That is, we substitute, we get 0.5 into 96,500, which is, we see our answer get is 48,250 coulomb. Therefore, our answer matches with option B. Therefore, option B is the correct answer. What is the equivalent mass of a metal having electrochemical equivalent of 3.4 into 10 to minus 7 kg? I give 4 options. So we have E equal to Z into 96,500. If we substitute the value, we get 3.4 into 10 to minus 7 into 96,500. Which is, if we see our answer, we get as 3.81281 into 10 to minus 2 kg. Therefore, our answer matches with option B. Therefore, option B is the correct answer. Question 13. 1.8 gram of metal was deposited by a current of 3 ampere for a 15 minute. The equivalent mass of metal is, we have 4 options. We have W equal to E into I into T upon 96,500. Which is, we substitute the value. We have W as 1.8, where we need to find E. We have I, that is 3 ampere, and time as 15 minutes, which we convert into seconds. We get 15 to 60 upon 96500. Therefore, we solve for E, which we get as 19.3. That is, our answer matches with option C. Therefore, option C is the correct answer. Question 14. Quantity of electricity which liberates 108 gram of silver from silver nitrate solution is equal to, we're given 4 options. We have 108 gram of silver, which is equal to 1 mole of silver. Therefore, we see G plus at aqueous plus of E, that is electron, gives us Ag solid. So charge on 1 mole of electron, that is 1 farad of electricity, is required to liberate 1 mole of silver nitrate solution. Therefore, we see that 1 farad of electricity is required to liberate 1 mole of silver. Therefore, 1 farad, that is option C, is the correct answer. Question 15. Number of Faradays required to liberate 2 gram of hydrogen is, we are given 4 options. 1 Faraday of electricity liberates 1 gram of equivalent, that is 1 Faraday is equal to 1 gram of equivalent of hydrogen. Therefore, 2 gram of hydrogen is equivalent to 2 gram of equivalent of hydrogen. Therefore, 2 Faradays of electricity are required to liberate 2 gram of hydrogen. Therefore, answer, that is A2, is the correct answer. Question 16. How many coulombs are required for the reduction of 1 mole of Cu to copper, that is Cu plus 2 to copper? That is, we say Cu plus of 2 plus of 2E gives us Cu. So charge of 2 moles of electrons is required to reduce 1 mole of Cu plus 2 to Cu. So charge on 2 mole of electron is equivalent to 2 into 96,500 coulomb, which is equivalent to 1930 coulomb, which is 1.93 into 10 raised to 5 coulomb. So therefore, we see the answer matches with option C. Therefore, option C is the correct answer. Question 17. 1 farad electricity is passed through aluminum sulfate. Solution number of atoms of aluminum deposited at cathode will be. We give 4 options. So we have aluminum of 3 plus of 3 electron gives us aluminum. So therefore 1 aluminum atom absorbs 3 electrons. So 1 mole of aluminum will absorb charge of 3 mole of electrons, that is 3 farad. Therefore 3 farad is equivalent to 1 mole of aluminum, which is equivalent to 6.023 into 10 raised to 23 atoms of aluminum. That is 1 farad is equal to 1 by 3 mole of aluminum, which is equivalent to 1 by 3 6.023 into 10 raised to 23 atoms of aluminum, which is, we see when we solve this, we get 2.008 into 10 raised to 23 atoms of aluminum, which is, we see our answer matches with option B. Therefore option B is the correct answer. Question 18. The number of electrons required to deposit 1 gram of atom of aluminum, that is atomic weight, is given as 27 from a solution of aluminum chloride will be, where N is the Avogadro's number. We give 4 options. Aluminium, that is at aqueous level, accepts 3 electrons to form 1 aluminum. That is 1 gram of atom is equivalent to 1 mole for aluminum. So 1 mole, that is 27 gram of aluminum, is deposited by charge of 3 moles of electrons. So 3 Avogadro's electrons are required to deposit 1 gram of atom of aluminum. That is, we see answer C, that is option C is the correct answer. Question 19. The atomic weight of iron is 56. The weight of iron deposited from iron chloride solution by passing through 0.6 Faraday of electricity is. We give 4 options. 1 mole of iron requires 3 electrons, that is, we get Fe(S). That is 56 gram of iron is deposited by 3 Faraday of electricity. So 0.6 Faraday will deposit at 56.06 upon 3, which is equal to 11.2 grams. Therefore, we see answer matches with option B. Therefore, option B is the correct answer. Question 20. How long will it take to deposit 100 gram of aluminum for an electrolytic cell containing aluminum oxide using a current of 125 ampere? Atomic mass of aluminum is given as 27. Therefore, we are given 4 options. So, equivalent mass of aluminum is given as atomic mass upon valency, which is equal to 27 upon 3, which is equal to 9. Therefore, we have W equal to I into T E upon 96500. Therefore, we solve for T. We get T equal to 100. We substitute the value 96500 upon 125 into 9, which is equal to 577 seconds, which is equal to 143 minutes, which is, we see our answer matches with option B. Therefore, option B is the correct answer. Question 21. The current in amperes when 11.74 gram of nickel is deposited from a nickel ion solution in 1000 second is given as. If we give 4 options over here, if we have W is equal to Z into I into T, that is which Z is equal to E upon 96,500, which is, we can write for E, we find E is equal to atomic mass upon valency is equal to 58.7 upon 2. Therefore, we can substitute the value of E in the formula. That is, we solve for I, which we get I is equal to W into 96500 upon E into T, which is equal to, we substitute the values, we solve for that, we solve for I, we get as 38.6 ampere, which is, we see our answer matches the option B. Therefore, option B is the correct answer. Question 22. The amount of electricity that should be passed through copper sulfate solution with copper electrodes to deposit 0.1 gram atom of copper is given as 4 options. So we have W equal to Z into Q, which is Z is equal to E upon 96,500, which you get Z is equal to 63.5 upon 2 into 96,500, which is 1 atom of copper gives 2 electron as it is divalent. So E equal to, we have 63.5 upon 2. Therefore, W is equal to 0.1 gram of atom. Therefore, for copper, 1 gram atom is equal to 63.5 grams. That is 0.1 gram atom is equal to 6.35 grams. That is Q equal to W upon Z, which is equal to 6.35 into 2 into 96,500 upon 63.5, which is, we solve this, we get as 19300, which is equal to Coulomb, which is, we see our option matches with, our answer matches with option C. Therefore, option C is the correct answer. Question 23. The EMF of the following cell at 25 degrees Celsius is, we're given reactions over here. So given value for E0, we are given standard potential for iron, that is equal to minus 0.44 volt, and for copper it is given as 0.337 volt. We give 4 options over here. So the standard potential cell is equal to standard potential red, that is cathode, minus of standard potential red anode. When we substitute the value, we get 0.337 minus of is 0.44, which is equal to, we get as 0.337 plus of 0.44. We get the value as 0.77 volt, which is, we see our answer matches option B. Therefore, option B is the correct answer. Question 24. Standard cell potential for F2 plus of 2E, which gives us 2Fe, is 2.8 volt, and standard potential for half of F2 plus E, which gives us F is given. We are given 4 options. So electrical potential in an intensive property is an intensive property. Thus, whenever the half reaction is multiplied by a numerical factor to balance the number of electrons, the corresponding standard electropotential value is not to be multiplied by the factor Therefore, that is standard potential cell is always fixed or constant. Therefore, the value, that is 2.8 volt for F2 plus 2E to Fe, is same for half of F2 plus E, which gives us F negative. That is, we see A, that is 2.8 volt, as a correct answer. Question 25. Which of the following is a strongly electropositive? We are given four options. Smaller the reduction potential, more will be the tendency to get oxidized. Conversion of metal to electropositive ion is oxidation. Since potassium, we see, has lowest reduction potential among the given option, so it will be strongly electropositive. Therefore, option D, that is potassium, is the correct answer. Question 26. The two electrodes of platinum fitted in a conductance cell are 1.5 centimeter apart, while the area of cross section of each electrode is 0.75 centimeter square. The cell constant is given as, we given four options. So we have cell constant as B equal to L upon A, which is equal to 1.5 centimeter upon 0.75 centimeter square, which we solve this, we get as 2.0 centimeter, that is per centimeter, which is, if we see, our answer matches with option D. Therefore, option D is the correct answer. Question 27. A conductivity cell having cell constant 8.76 per centimeter is placed in 0.01 mole solution of electrolyte offer to resistance of 1000 ohms. What is the conductivity of the electrolytic solution? We are given four options. We have K equal to 1 upon R into B, where K is the conductivity, R is the resistance, and B is the cell constant. So we solve for K, we get K is 8.76 upon 1000, which is, we get K equal to 8.76 into 10 raised to minus 3 per ohm per centimeter, which is, we see, our option matches with answer matches with option C. Therefore, option C is the correct answer. Question 28. Faraday's first law of electrolysis gives us the relation between, we're given four options over here. Faraday's first law of electrolysis gives us the relation between the amount of substance deposited or dissolved and the quantity of electricity. Mathematically, Faraday's first law of electrolysis can be expressed as W directly proportional to Q, where W is the amount of substance deposited or dissolved in grams, and Q is a quantity of electricity passed in coulombs. Therefore, we see our option A, that is amount of substance deposited or dissolves and the quantity of electricity, is a correct answer. Therefore, option A is a correct answer. Question 29. 1 coulomb is equal to charge on, we have given four options, which is in electrons. So charge on one electron is equal to 1.6022 into 10 raised to minus 19 coulomb. Therefore, we see one charge, we get as 1 upon 1.6022 into 10 raised to minus 19 electrons. Therefore, we solve it, we get as 0.6241 into 10 raised to 90, which is, we can write this as 6.241 into 10 raised to 18 electrons. That is, 1 coulomb is equal to charge on 6.4, that is 6.241 into 10 raised to minus 18 electrons. Therefore, we see our answer matches with option C. Therefore, option C is the correct answer. Question 30. 1 Faraday of electricity will liberate half gram of atom of the metal from a solution of, we give four options. So 1 Faraday will liberate half gram of atom of the metal. So charge on 2 mole of electrons, that is 2 Faraday, is required to liberate 1 mole of metal. This indicates that metal needs to be T positive. Among the given options, BA in BaCl2 is D positive. Therefore, option C is the correct answer. That is 1 farad of electricity will liberate half gram of atom of the metal from the solution of BaCl2.